Hello class, it's Ms. Augustine, and we're going to continue along with our quantum mechanical model of an atom notes. So first of all, it's really important to know why we spend time talking about the quantum mechanical model and why we spend time with these quantum numbers and why we have all these different quantum numbers. And what it's really about is, if you want to understand chemistry, chemistry is about what's going on with the electrons. When atoms encounter one another, they're going to either do nothing or there's going to be something going on with electrons either being shared or exchanged. So it's important to know for any given atom what the electrons are outside of it and where they're located, because that's going to determine the chemical properties. So we spend time figuring out exactly where the electrons are, and this set of quantum numbers that we talk about is really a way of indicating not just where the electrons are with regard to the nucleus, but where they are, what the probability of finding them is, what their energy is. The energy dictates the shape of the path that they follow, and all of that tells us whether they're going to hang tight or whether they're going to be reactive and get involved with other atoms. So I'm going to start with a recap of the quantum numbers that we've talked about so far. And that starts with the principal quantum number. And that quantum number is about the energy levels. So the principal number tells you how many possible energy levels there are, and they're assigned numbers according to their energy. And the numbers are integers from 1 through 7, with 1 being the lowest energy, closest to the nucleus, and 7 being the highest energy, farthest from the nucleus. The second number we talk about is the angular momentum quantum number, which indicates the shape of the orbital. So each principal energy level has one or more sublevels, which means it has one or more possible orbital shapes. And the number of orbital shapes associated with an energy level is equal to that energy level number, n from the previous bullet right here. So that means that if you're at n equals 1, you have one sublevel, which means one shape of an orbital. And we saw in the previous slides that 1 is an S. It's called S, and it's a spherical shape. We saw that level 2 has two sublevels that can be S and P. 3 has 3 SPD, 4 has SPD and F, and so on. Then the next quantum number that we talked about was the magnetic quantum number, and that really indicates the orientation of a particular orbital around the nucleus. So what that number tells you is how many orbitals there are per type of sublevel, where S has 1, P has 3, D has 5, F has 7, and G has 9. And there's a typo there, but I'm just going to keep forging ahead, folks. I apologize. So now the last quantum number that we talk about is the spin quantum number. And the spin quantum number has two possible values, +0.5 or -0.5, which again is about the orientation of the particular electron. Each orbital can only contain a maximum of 2 electrons. So if you're talking about an S type of sublevel, which has just one orbital, then each S orbital can hold 2 electrons, and we talk about them as having +0.5 or -0.5 spin. Another way of thinking of them is saying that they are pair spin paired, or spin coupled. So if you're thinking about it, if electrons are going to hang out in the same orbital, they have to have a way of coexisting. And again, the spin quantum number tells you that. So n equals 1 has only that one sublevel, as I said, which is called S. And the maximum number of electrons for this level is therefore 2. So if you're thinking about a p sublevel that has 3 orbitals, each of those 3 orbitals can contain 2 electrons, so 3 times 2 equals 6, for instance. So here is a table that lays out the energy level the number of sublevels, here's the type of sublevels, and then the total number of electrons. So let's take them one at a time. At principal level 1, there's only one kind of sublevel. It is the S sublevel, which is spherical around the origin, so around the nucleus in this case, and it can hold a maximum of 2 electrons. Then at n equals 2, you have 2 sublevels, S and P. Remember, S has 1 orbital, so it holds 2 electrons. P has 3 orbitals, so 3 times 2 equals 6 electrons. So this is where the number comes from. 2 plus 6 equals 8. Then at n equals 3, there are 3 sublevels. They're called S, P, and D. S has 1 orbital, P has 3, D has 5. So if you think about the numbering, 2, 6, and 10, which is where 18 comes from, and then at n equals 4, S has 1 orbital, P has 3, D has 5, F has 7. So if you add those up, 7 times 2 is 14, 5 times 2 is 10, 3 times 2 is 6, and 1 times 2 is 2. Add those up, and that's where you get your 32. So in your packets for Chapter 4, this is Chapter 4, right? Yes, Chapter 4, sorry. In your packet, there should be a worksheet that looks like this, which asks you to fill out the principal energy level, the number of sublevels, the type of sublevel, number of orbitals, and maximum number of electrons. So what I'm going to ask you to do is I'm going to ask you to pull out your packets at this point, and then the next slide is going to show you how to fill in that worksheet page. So we'll go here, and it's also on table 2 in your textbook on page 110. So what you could do at this point is you could pull out your worksheet packet, and after I'm done talking, you could replay this video and pause it at this point so that you can all fill this in. So here again, principal level 1, there's 1 sublevel, it's called S. It has 1 orbital that holds 2 electrons, 2. And then here, level 2 has 2 sublevels, the S and the P sublevel. 1 orbital, 3 orbitals, so 1 times 2 is 2, and 2 times 3 is 6. So there's 8. And then the third level, the S, the P, the D, layering, and the fourth, the S, the P, the D, and the F. So the maximum number of electrons at these levels are, for the principal level 1, 2. For principal level 2, 8 possible electrons or total electrons. For principal level 3, we're talking about 18. And principal energy level 4 can hold 32 electrons. Then there's a second page in your packet, hopefully, and it looks like this. And so again, what I've done is I have filled out a chart for you for the top table in that worksheet. And here it's broken down into sublevel, number of orbitals, and total maximum number of electrons. So S, 1 orbital, 2, P, 3 orbitals, 6, D, 5 orbitals, 10, and F, 7 orbitals, 14. So now I'm going to suggest that you please take out your Chapter 4 packets, fill in those 2 worksheets, and please feel free to play the video again and pause it so that you can fill in those 2 worksheets. And I'll be recording another video shortly. This is Ms. Augustine signing out. I wish I could be with you guys, but my stupid broken arm is still not allowing me to return to school. Hopefully I will see you soon after Thanksgiving.